Okay, guys. So, in the previous class, we discussed vectors and we talked about the first operation on vectors, that was addition. Okay, and we talked about the triangle law, we talked about the parallelogram law, we talked about some equations which will help you to give the magnitude and the direction of the resultant, and I think we solved some numericals as well, right? Okay, so the formula, if you remember, for the magnitude of the resultant was this, right? And for direction, we had this. I think, yeah, we solved some numericals as well. So today, we are going to discuss how do you subtract vectors. If you have two vectors, A and B again, the angle between them is theta, and if you are asked to find their difference, to find their what? Difference, okay? How do you find that? That is more important. So for difference, first of all, you need to understand we do not subtract vectors. Vectors are not subtracted. Then how do we operate subtraction for vectors? See what we do. Now, when we talk about the concept of subtraction in the case of vectors, what we do is, for example, there are two vectors. There is a vector A and then there is a vector B, such that the angle between them is theta, okay? And if someone tells me what is A minus B, okay? So whenever you have to subtract the vectors, remember the first important thing is we do not subtract vectors. Then how do you do this? What we do is we add to vector A, the negative of B. Is that clear? We add to A the negative of B. That means, see, the negative of B will also be a vector of the same magnitude as that of B, but its direction will be reversed. If A is, say for example, B is along this direction, and if you want to find the negative of B, same length arrow, but on the opposite side. Is that clear? Is it clear? This will be negative B. If this is B, negative B this time would be downwards. Same length of the arrow, but reverse the direction. Is that okay? That will be the negative of the vector. So we have A, we have B. What we are doing? We have to find A minus B. So we will add to A the negative of B. So first of all, what we have to do? We have to draw the negative of B. Is that clear? So here, when you try to draw the negative of B, so for negative of B, I'll go like this. See, here is there. This is negative of B. Is that clear? Now we'll do the same thing that we have done in addition. We will add to A the negative of B. Halas. So the angle this time is not theta. Understand, the angle here is 180 minus theta. Is that clear? Isn't it? So initially in the previous concept of addition, you were adding two vectors A and B. Today you are not adding A and B, you are adding A and negative B. Is that clear? So the angle has to be between A and negative B itself. The original angle that was given was theta, but the angle between A and negative B is 180 minus theta. Is that fine? Obviously, when you have to find the resultant, you have to use the parallelogram law, or you have to use what? The triangle law. Is that clear? Now here in this case, it is better to draw the parallelogram law, and as per the parallelogram law, if you remember, if you try to form a parallelogram with the help of A and negative B, so what will be the parallelogram? Will it be something like this? Yes? The diagonal gives the resultant. Do you remember that? The diagonal gives the resultant. So this is the diagonal, and this will give me the resultant. Is that clear? Is that fine? So the resultant would be A minus B. Is that okay? Fine? Now again the same thing. How do you find the magnitude of this resultant and the direction of this resultant? Do you remember the formulas for the last previous case? For the previous case we had, when you added two vectors, The formula was a square plus b square plus 2ab cosine of theta. And to find the angle, if you remember, I told you it starts with one of the vectors with which the angle is not given. So it is b sine theta divided by a plus b cos theta. Similar thing in subtraction as well. See, in subtraction we have two formulas. The angle between a and b was theta. But the angle between a and negative b is not theta, it is how much? 180 minus theta. So the formula gets changed a little bit. The formula for the subtraction, or in this case, as I have shown you, it is r, the magnitude will be given by square root of, again, a square plus b square, but negative. Subtract twice ab cosine of original angle that was given. Is that clear? Is that fine? And for the direction, again use the same thing. So alpha is the angle with, here in this case, alpha is the angle with a. This is alpha. Is that fine? Alpha is the angle with a. So we are left with b, so we'll be starting with b only. So it is b sine theta divided by a minus b cos theta. Previous was a plus b cos theta for addition, isn't it? Now because it is subtraction, the formula gets changed. It is negative in the denominator and negative here as well. That's the difference. For the magnitude and for the direction. For subtraction of vectors. Is that clear? Just memorize these two formulas. Don't memorize this because this is the proof, this is the final result, and this is also the final. Is that clear? Yes or no? So whenever you have to add the two vectors, what do you need? You need their magnitude, you need the angle. Whenever you have to subtract, you need the same thing. You need the magnitude, you need the angle. And if you remember the formula, then it is very much easier. Is that okay? Fine? Okay. So we'll try to see what is the application of subtraction. See, I'll tell you. For example, there is a body which is going towards north with a speed of 25 meters per second. Okay? And then it takes a sharp right turn and moves with 30 meters per second. If someone asks you what is the change in velocity, what is what? The change in? Change is what? Final minus? So you have to subtract initial velocity from the final velocity, isn't it? So subtraction is important. And in such cases, we have to understand how do you subtract. So I'll have the first numerical on subtraction, and here it is. Try to solve this. Two vectors of equal magnitude 2 are at an angle of 60 degrees to each other. The question is find the magnitude of their sum and difference. Find the magnitude. He is not asking you about the direction. He is just asking you about the magnitude of their sum as well as their difference. Yes. Anyone? What is the magnitude of their sum? What is the magnitude of the difference? Yes. Huh? Oh. You know the formula, right? You know the formula, just put in the values. Magnitude and 60, that's it. Formula? For the difference? For the difference? Yes. You didn't understand? Yeah. You know? Okay, let me give you an idea. The question is two vectors of equal magnitudes. Two. The magnitude is 2. So there are two vectors. Say there is one vector A and the other vector is B. Okay. But he's saying that the magnitudes are same. So magnitude is this and it is equal to 2. That's it. The angle between the vectors is 60 degrees. So theta is equal to 60 degrees. What is the question? Find the magnitude of their sum. So you know sum from this formula. See, we have done resultant in the previous class, right? And this is the formula. For sum, we have this formula, right? So what is the sum for these two vectors? Yes. Their sum will be given by square root of, yes, a square plus b square plus 2ab, yes, cosine of theta, isn't it? Yes. So put in the value. It is how much? 2 square plus 2 square plus twice. 2 multiplied by 2 into cosine of 6. This will be your sum. Is that clear? Now, what about the difference? What is the formula? What is the formula for difference? It is the same, just that here it is negative, isn't it? That's it. Why is it difficult? Understand. So difference would be a square, again 2 square plus 2 square, but subtract twice 2, another 2 cosine of 60. Now tell me the result. This is what? This is 2 radical 3? Yeah. And what about this? This is 2. So see the difference. The sum, obviously it has to be more differences. Yes, is that clear? Now, if I ask you, can anyone just draw the direction of sum and difference at their places? The direction of their sum, that is the resultant. Show me the direction of the resultant. Show me the direction of the differences. So I will draw the two vectors. Are these two vectors? If this is A and if this is B, if this angle is 60. Can you tell me in which direction will be their resultant? In which direction will be their resultant? Yeah, somewhere in between, right? Isn't it? Because the triangle law also speaks about the same thing. Or you can form the parallelogram. So parallelogram, if you want to use the parallelogram, see what you will do is you will just try to complete it, isn't it? And this will be the resultant, isn't it? So this is the resultant. Fine. Remember, whenever the case comes where two vectors are of equal magnitudes, two vectors are of their equal magnitudes. Remember, the resultant is always bisecting the two. So that means this angle will be how much? You can use the formula as well. For example, we have to find this angle. Okay? So then you remember the formula for tangent of alpha. Remember? If this angle was alpha here, then tangent of alpha would be calculated by b sine of theta. Yes? B sine of theta upon a plus b cosine of 60. Isn't it? Yeah? Can you tell me the result here? We'll confirm this is 30 degree. B is 2, A is also 2. So yes, what is the value? This will cancel, so it is 3. This will also cancel, so it is 1 upon root 3, right? So 1 upon root 3, tan of which angle is 1 upon radical 3? It is 30, right? So it confirms 30 degrees. Remember this. Whenever, say for example, you have these two perpendicular to each other. One is here and the other one is 90. Okay? Is at 90. What will be the resultant? Resultant would be here, 45. The value would be different of the resultant, but it will always bisect. Is that clear? Fine. So this is the resultant, this is the sum. Can you show me the direction of their difference? Opposite means? That means here, somewhere here? No, try to understand the definition. What did I say about difference? What did I say about difference? Whenever you have to find the difference, first you have to draw the negative of B. And then find the result, isn't it? So here in this case, first you have to draw the negative of B, isn't it? The negative of B is in which direction? Yes, anyone? The negative of B is in which direction? Yeah, is it like this? Right? Fine. Now, understand, very important thing. How much will this angle be? 120 degrees, isn't it? Yes. And then what is the difference? Difference is actually the sum of this and this, right? So their sum will again be in between the two because you again have to form a parallelogram. So when you try to form the parallelogram here, don't you think this is the resultant? Yes. But this will be their difference. Is that clear? Is that clear? So tell what is the angle with, for example, yes, it will also bisect, it will be x. Why? Because this is 2, the magnitude of negative b is also 2. So the resultant will always bisect. So it will be at 60. Now understand. Sum and difference are at what angle to each other? Sum and difference are at 90 degrees to each other, isn't it? Understood? Sum and difference in this case are at 90 to each other. So they can also ask you an extension of the same problem. They can ask you. Is that fine? That's how you have to approach them. That is how subtraction should be understood. So it is not always true that sum and difference is always at 90. No, not always. It is here because the magnitude of the two vectors is same. If the magnitude of the two vectors is not same, it will not be the case. Then you have to find the angle. Okay? But it was one of the easiest cases. Fine? That is how you have to approach subtraction. Clear? We'll try to solve that question. A body is going due north. A body is going due north with 25 meter per second speed. With 25 meter per second speed. Okay? With 25 meter per second speed. It takes a sharp right turn. It takes a sharp what? Right turn and moves with the same speed. It takes a sharp right turn and moves with the same speed. Okay? Find the direction. Find the direction and the magnitude of the change in velocity. Okay? Going towards north with a speed of 25 meters per second. Write it down, write down the question. She is having calculated in her hand. But whenever you speak of some number, she put it there. 20, and then what? Okay, another 25. Okay. And then she doesn't know what to do with it. Until and unless you draw the diagram, you'll not be sure. You have to subtract them. Okay, what did I say? A body is okay. Should I write it down? Oh my God, a body. My English is what? What was the question? A body is going north with a speed of. So you are dictating the question to me, huh? Okay, wait a second, man. It takes sharp right, okay? Right turn and moves with the same speed. Find the direction and magnitude of velocity, of the change in velocity, right? Change in velocity. Okay, see. So can you grab this? Can you try to solve it? Dulcie, home, you have to do it. Your pen is not working. Your pen is not working. If I would sleep all night. Well, the morning something, you must be doing something. Netflix, something. Being sorry. Yeah. Not there. Sure, try. This guy, this guy. Easy, easy. Wallah, wallah. Allah, Allah. Now you got the answer on your trade calculator. Yes. Excuse me, everyone. What is it? Can you show me the direction from where is north? Yes. Some will say like this. Some will say like this, right? But no one will say like this. Is this north? Oh my God! But she is actually correct because the actual magnetic north is tilted at 15 degrees. But she doesn't know what she did, but she's wrong. Why? Yes. Yeah, see, understand what is my. Do you know what is the full form of news? Cover. Isn't it? This is news. See, NWS news. Okay. See. The body is going towards north. So initially, the speed is something like this, isn't it? This is initial. It takes sharp right. Okay. If I ask all of you, what do you mean by sharp right? East, isn't it? If I'm going here, then sharp right is this, right? Or sharp right is this. Or sharp right is this. This is U-turn. This is sharp right. Right? So that means if I'm going like this and taking a sharp right, this is my final velocity, isn't it? Find the direction and magnitude of the change in velocity. So we have to find the change in velocity. Now you know change is given by, yes, final velocity minus initial velocity, correct? So we have to understand, very important. We have to add to the final, yes, the negative of the initial, isn't it? So we have to draw negative initial velocity. The negative initial velocity will be something like this. See? If this is Vi initial, what will be its negative? South, isn't it? An arrow of the same length but in south direction. So I draw it here. Is that fine? Is that clear? This will be negative Vi. Fine? You can draw it here as well, no problem. But then we have to find the resultant. So that is why I drew it there. I drew it here. Is that fine? So if this is V final, this is V initial, negative V initial, you know the triangle law. Correct? As per the triangle law, the resultant is given by the third side, but you have to reverse the order. Remember? So this is the order. See the order is from this point it is going to right and then it is going down. So the order would have been like this. Correct? But we have to reverse the order. So when you reverse the order was something like this. So this will be change in velocity. Is that fine? Did all of you arrive at the same diagram for the change in velocity? Yes, so we have the direction, right? So what is the direction? It is somewhere here, isn't it? What is this direction? How do you stay? How do you Name this direction. Southeast, yeah. Because, understand, because this angle and this angle is 45. What? Because this is 25, this is also what? When two vectors are of equal magnitude, the resultant always bisects them. That's what I said. Whenever the angle is bisected, remember you can say southeast or you can say east of south, anything. But if the angles were not same, then you cannot say southeast. Is that right? Then you have to mention the angle. Fine? What is the magnitude? Yes? The magnitude will be given by the formula, right? And the formula is 25 square plus 25 square. What is the angle between the vectors? So at 90, cos of 90 will be 0. The third term is not needed. Is that right? Because that is still going to be 0. You have to subtract that, but that is still 0. No problem. So it's 25 square plus 25 square, which is 2 times 25 square root. So this and this will cancel out. Oh, this is 25. So this is 25 square root. All you are at the same values? Yeah. Yes? Do you understand the direction? Yes. The body is going north and it is going towards east. The change is south of east. Is that fine? Oh. Okay. Is that clear? Now, let us come to one of the. This question is on resolution. You did resolution in the previous class, right? One. We got direction 45 degrees. It is 25. This is also 25. When the magnitude of vectors is same, it always bisects. So the angle was 90, it will be at 45. Otherwise, we can use the formula. That will be 1. So tan of which angle? 45. Tan inverse of 1 is 45. So it is at 45. Good. See, this question. There are two forces. One is 12 Newton, which is 45 degrees with the horizontal, okay. And then there is another force, 10 Newtons, which is 30 degrees with the negative x-axis. So the question is, find the x and the y components of the resultant force. We have to find the resultant force and then find its components, its x component, its y. So this is again addition, but this is addition by resolution. Addition by. So if you remember in the last class we did resolution. Let me come back to that. Yes, here it is. See, if this is a vector and the angle with the x-axis is given, then I told you. If this is the x component, then Vx will be given by V cosine of theta, and sine component will be the vertical component. Is that fine? Similarly, we can use this approach in this problem. If, for example, this is 12 Newton, it will have two components. One will be here, and the other one will be here, right? Isn't it? So this component, will it be 12 cosine of 45 degrees? Yes. And what will be this component? Yes. 12 sine 45. Is that clear? Yes. Similarly for 10 newtons. For 10 newtons, the resolution will give me two components again. One will be here, which will be the sine component, and then we will have this component as well. So this will be 10 cosine 30, and this will be 10 sine 30. Is that fine? Yes? So, with the help of these two, understand what is the net resultant in x? Resultant value of the force in the x direction. See, we have two forces in the x, right? One is 12 cos 45 and the other is 10 cos 30. So, one force will be more, one will be less. So, whichever is more, will be that will be the net direction of the x component, isn't it? Someone is, see, there is a pen and someone is trying to pull it here and someone is trying to pull it here. So it will go along the direction of the maximum force, right? Of the larger force. So we have two forces. One is 12 cos 45, another is 10 cos 30. Which one is more? Yeah, try to solve it. Which one is more? 12 cos 45 or 10 cos 30? So this will be 10, 12 upon root 2, right? And this is just 5. What? This? Cos 30. Oh, cos 30 is root 3 by 2. But that is 5 root 3? Yeah. Oh God, this is the same. 12 can be written as 6 into 2 divided by square root 2. So square root 2 and 1 square root will go, so to this 6 square root 2. Which is more? Which is bigger? 6 root 2. So the net will be 6 root 2 minus 5 root 3, right? Is that fine? What is the value? This is how much? Root 2? Which one is 8.6? 5 root 3? 5 root 3 is bigger? Okay, it's fine. This is more, this is minus. That's it. Because the net direction, see, understand. Whichever is more, the net will be along that direction. Is that fine? So 5 root 3 is more, 6 root 2 is less. So that means we'll have a net here towards the negative x-axis. Is that fine? Yeah. 6 root 2 is 5, 1.7. Again. Yeah, I'll write those values only. So it is 8.6. And how much is this? 8.4. Okay. So more is towards left. So the net component along the x-axis is towards left. Towards left. And the value would be 8.6 minus 8.4. Is that fine? Yes? So it is how much? 0. Is that clear? This is your x component. Y component. Will they subtract or will they add? There are two forces trying to pull it up. So they will add, right? So the net along the y direction will be the summation of the two. So 12 sin 45 will again be 8.4, right? And 10 sin 30 would be 5, right? So how much is it? 13 point. Is that fine? And it is up. Is that clear? So now understand. We have 12 newtons and 10 newtons. Very important. We are adding 10 newtons and 12 newtons by resolving them into components. We found the components about x-axis and then along the y-axis, and we are adding the components. Now we know that these two forces, when they add up, they'll produce a net 0.2 newton along the negative x-axis and 13.4 along the positive y-axis. Is that fine? So if I have to draw these two on the graph, I will show them something like this. See, important. In the y-direction, I have 13.4, isn't it? And then one more here. How much is that? 0. Isn't it? Now understand. We have to find the magnitude and the direction of the result. So, if you have to find the magnitude, do you think there are two vectors perpendicular to each other? Yes? Two vectors perpendicular to each other. The resultant will be given by the diagonal as per the parallelogram, isn't it? So if this is the parallelogram, this will be the result. That's it. What will be the value of the resultant? Yes? Magnitude. Tell me, square root of, yes, a square plus b square, isn't it? Plus twice AB cosine of 90. Cosine of 90 is again 0. We don't need to take that. Is that fine? It gets much easier. So when you try to add the vectors with the help of their components, you break it into components, then find net along x, find net along y, draw a new diagram, and then use this formula. That's it. Give me the value. Yes? How much is this? Again 13.4? Yeah. So the net is 13.44, something like that. 401. Okay, this is the net resultant. Now the question is, see, the two forces were what? One was 12 and one was 10. So the answer is 13 point something. And what about the direction? What about the direction? Where do you think this force will be directed? So we have to find the angle, isn't it? So let this be alpha. Is that fine? We try to find alpha. So if you have to find tangent of alpha, see, tangent of any angle is perpendicular by base, opposite by base, isn't it? We can use the formula that we already know, but this is a right angle triangle, right? In right angle triangle, simply use tangent of alpha, which is perpendicular upon base. Perpendicular is 13.4, base is 0.2. So you can simply divide 13.4 by 0.2. What is the value? 2.35. Is it? That is the angle. Angle? So that means this alpha is 89.14 degrees. So this is the angle. Is that clear? Is that fine? So that means when these two forces are trying to pull it up in this direction, the body will go somewhere there. See, where will it go? It will go at 89 degrees. So it means it will go somewhere here, isn't it? And with what value? 30. Is that clear? This will be 89. This is the result. We have not used the vector addition. We have simply resolved and found what is going to happen. A different approach for the addition. There were two vectors, one was 10, another was 12, trying to drag a body, trying to pull a body, and we are seeing, see, understand, how many people are employed to do this work? Two people, isn't it? One is applying 10 newtons, another applying 12 newtons. I asked both of them, lay off, the company doesn't have money for you. I'll bring only one person, ask him to apply 13 newtons of force at 89. He'll do the same work, right? And I have to pay only one person, the yellow person. Otherwise, I have to pay this guy as well as this, isn't it? That is the effect of it. Is that fine? Okay, so I think addition is done. We have one question. This question, try to do it at your place. This, again the same thing. Find the x and the y components, also find the magnitude. You have 10 and 8 Newton this time. 10 is at 30 degrees with the horizontal, okay? This is x and this is y. And 8 is along the x-axis, so it's not a problem. This is much easier. Try to solve it, I'll check it here. And that will be it. Inshallah, tomorrow I'll be starting with, how many of you want electricity and magnetism? Electricity and magnetism. So I'll be starting with basics of current and I'll develop on that, go towards magnetism as well. Is that fine? Inshallah, we'll be doing that. Don't worry. Yeah, try to solve this at least. In this case, how many vectors do you resolve? Both or single? Yes? In this case, how many vectors are there? There are two vectors, one is 10 and another is? Do you need to resolve it? It's already along x, you don't need to resolve it. Just resolve 10, find the net values along x and y, and then draw a new diagram, and the same thing will go again. So the first, what is x? For this, 10%. 10. What is the net x? Yeah. So it is net here, and we have up value. So new diagram on the two values. Yes. Hint. No. My, see, for 10 newtons, you have to resolve. It will have two components, one will be here and the other one will be here, right? What will be this? 10 cos 30, is it? And this will be 10 sine, right? We don't have to resolve this. So, what is 10 cos 30? 5. And what is 10 sine 30? 5 root 3? 5 root 3. And this is 5, isn't it? So, 5 root 3 is 8.6. So, which is more? 8.6 or 8? 8.6 colors. So, it means net x, the resultant along x is 0.6, isn't it? Towards right. Is that right? What about y direction? Yes? Only 5 newtons and it is up. Is that right? Now you got the two components. Draw a new diagram, show these two components and find the resultant. Is that fine? So we have to show two arrows. One is up, which is 5, and one is towards right, which is 0.6. So if I try to show it on maybe, where can I show this? Maybe there. So I'll try to make it here. See, it is something like this: 5 and 0.6. Is that clear? What will be the result? The result will be somewhere here, isn't it? Now find the resultant. Resultant would be square root of, yes, 5 square plus 0.6 square. What is the value? Plus twice AB cos of again 90. We don't have to do that. See what is the beauty of this resolution. Angle is always 90, so you don't need to take third term. 5.03. You found the resultant. Is that fine? Now the direction. Let this be alpha. Again go forward. Tangent of alpha. So tangent of alpha would be equal to perpendicular, which is 5, upon base, which is 0.6. So it is 5 upon 0.6. Tell me the value of alpha now. Direct tan inverse of this. Khalas. So it is 83.15 degrees. So that means this angle is 83.15 and the value is 5.0. Is that clear? So that means these two guys are effectively taking the body somewhere here, isn't it? With 5 point something and at 83 degrees. Is that clear? Yes. So that will be it. That is it for promectin. 10 sine? No, 30, because this angle is. If you have to write sine 60, that means this angle had to be 60. The angle with this component, with x-axis, is 30 degrees. So you have to consider only 30. If you consider this angle, see, very important. If you take this as 60, isn't it? This is 60. Then this is not 10 sine of 60. This is 10 cos of 60. Understood? So that is why I give you the trick. With whatever axis the angle is given, take the cosine component. The other will always be sine. But the same angle. Is that fine? Any doubt? Anyone? So this is from vectors. Hopefully in the next class will be, I had thought of going for multiplication as well. But now that you have given your responses in the spreadsheet about electricity and magnetism, let me take up the concept of current tomorrow, inshallah. Is that fine? Thank you so much. And I have already asked you, you are free to ask me anything from any subject on any day. No problem. You have my email IDs as well, don't worry.